Hello, I'm Nandika D'Souza. I'm in the College of Engineering. My research is focused on extending the engineering performance using material selection and design. My journey of discovery and why I love research is really best expressed by this quote that I keep from T.S. Eliot. It says that we shall not cease from exploration. And research really offers you the opportunity of constantly realizing your curiosity. And the most beautiful part of learning is that we go through the process of learning and we come back to the question that got us started and see it as if it was the first time. When I first started in college, a professor made the comment that every transformational technology that had been realized was limited by the materials and energy available to the people to make it real. And he gave me the three areas: the Stone Age, Bronze Age, and the Iron Age. As time has evolved and I became aware of the depletion of the environmental concerns in our society, I decided that my research would be focused on a new green age concept. And every age before had led to depleting the earth. I wanted to make sure that my research was focused on renewal. With that in mind, my research is focused on design and material selection to extend the lifetime of anything that we design, and to use renewable resources and sustainable materials wherever possible. A good example of how materials limited the abilities of design engineers is captured by Leonardo da Vinci, whose design of the helicopter took centuries to be made into a reality. He also looked to nature for inspiration, and he looked at bats to sketch what would later become a plane. To design the materials that could be lightweight and make a helicopter, engineers looked at wood, and they looked at the fibers that are created in the growing direction of a tree. This results in fantastic performance in one direction, but should even the slightest hit arise, we see that the part can break. So what did engineers do? Engineers did research to realize that you could take different layers, sequentially place them, and make a performance that was not possible by nature. So while being nature inspired, engineers use their analytical skills to create new designs. This is the heart of my research, which is composite two-component systems, where one component is typically a fiber and another material is the resin or the glue that holds it together. This concept of layering enabled new technologies. You have the V-22 Osprey that can take off like a helicopter and fly like a plane. This was only possible due to the mechanical design that was enabled through the layered structure of composites. Nowadays, our research is focused on new needs arising from unmanned autonomous vehicles. This requires a new approach. It requires reaching out to different departments, working with computer scientists, electrical engineers, because the entire system has to perform. Our research in this arena is focused on averting some of the challenges this technology faces. The biggest challenge with unmanned vehicles is related to the flight time. This means the battery has to be conserved. This can be enabled through lightweight structures, which is where we focus on new designs. The other aspect is unmanned vehicles enable new opportunities to fly into dangerous territories. Therefore, surveillance, chemical sensing, those are functions that can be embedded in a material system. And finally, the noise from this drone flying around is going to cause us to be more and more concerned. So we utilize new concepts of design and material selection to enable acoustic sound tuning. Our students and I have worked together, and here is the example of a team of 4 undergraduates who put together different lattice structures. What does this do? It enables us to utilize the strength of the walls, the frames, to make performance while enabling us to lower weight through the air of the enclosure. Further, engineering undergrads utilized our design concepts, simulated the performance so that we can think about different structures. Utilizing the area between the struts, they were able to create new mechanical performance that had not been realized before in solid materials. What did happen because of that? Because of that, we were able to increase the strength of the material in a very sequential manner. More important, for lightweighting, we developed a new paradigm that helped us to see that just increasing materials does not realize an optimized space. There is a kind of secret position that would realize both high strength as well as lowest weight. Our students also looked at what can we do with embedded sensing. Can the drone fly and be able to sense the stress as it flies over? By utilizing small particles into the material, they're able to detect the stress that is in the system. The vibrations created on the wing are able to be captured through an embedded sensing as we partner with electrical engineers in our lab. What happens when we have this stress application? You both see that the particles move apart, but by tuning the resin between the particles, we are able to create a material that can recover back to the original shape. This has led us to create new different shapes and that could change shape through shape morphing technologies that could, through a electrical current, cause a temperature change that would realize in shapes both going back to the original position and sequentially returning to its shape. You could apply stress and it would recover. Our research has also explored bio-inspired designs through the fibers which comprise these composites. We looked to nature and we created new fibers that we harvested from a plant grown in Texas, working with the biology department. This has resulted in a material that has the same specific strength as fiberglass. We use these fibers in the Zero Net Energy House in Discovery Park, and we're able to create sandwich composites of skins and foam cores that could have embedded sensing that would be able to sense whether this particular hurricane caused damage that required a panel to be replaced. We then took these panels further in our most recent research. We put fibers from paper that was previously thrown out for waste, but we incorporated it into a corn-based plastic. And we created a material that could actually match the energy consumption of the current petroleum-based resources while saving energy. The best news is that these materials, when the use is completed at the end of the life, they can be dropped into the earth and become compostable as our student investigates in our compostability system. We've taken the plant designs further and we utilize a hierarchical system so that we can create new functions of porous and non-porous materials that can be used for biological drug delivery and to increase the function of fibers like they've never been used before. The materials are used as biomedical sensor meshes and textiles. In summary, my journey of discovery has been to, again, highlight the joy of this exploration, to keep learning, finding out. I encourage all of you to embrace the experience of the journey that you are on beginning. You're going to get to meet people from all disciplines, cultures, race, and gender, and to engage with them, engage with the campus community, drop into seminars, connect with instructors, ask to visit their group meetings. Enjoy the pauses in between. I always take non-electronic time to just ruminate and process all the learning that has happened and explore career paths that will bring fulfillment to you, that pairs your values and your capability. In summary, the theme that I put as the that underscores my journey is I would like to continue embracing intellectual, racial, gender, and cultural diversity and excellence in engineering. Thank you.